Hello and welcome back. And in this video, we're going to be taking another very interesting stack-related question. And this one is related to the previous one. So previous one, we actually computed the valid parentheses, right? In this interview question, the interviewer asks us that we know that there is a string that has a valid parentheses, but we need to find out the length of that well-formed valid parentheses. So, for example, if you have, let me read the question first. So, given a string containing just a character, open parentheses and close parentheses, find the length of longest valid well-formed parentheses substring. Okay. So one point is you're only given the open bracket and close bracket. So there's no square or curly bracket like the one that we saw in the last time. Okay, so it's only one case that we need to handle. And then the example is you have this open and closed. Now, if you look at this one, the longest valid parentheses is actually of length 2 because this is the valid parentheses, right? This is not valid. This is not well formed because there is no closing for this one. Similarly, this parenthesis starts with an open and ends with an open, but these four are actually valid. Okay, so that's why longest valid parentheses is actually these four. Okay, so that's the question. So take a look, and I would say pause the video here and take a first stab at solving. Once again, this is something stack related, so think in that term, and hopefully you'll get to a point to form an algorithm, and then come back and look at our solution. Hello and welcome back. So hope that went well, and I know it's it's a little bit mind-boggling, how you're gonna compute all these. So let's take a look at the scenario in the code. Okay, so let's take a look at this simplest case. So you have open and you have close, right? This is your string that's being given to you. Now, if we leverage the fact that we have a stack, we can store the previous the index of this into a stack, right? Index, not the parentheses itself. Now, what that gives us is basically whenever we encounter a closed parenthesis as a character, we say, hey, compute the length between the last index and the current index and give me that distance. Okay, and then we keep it as a running total for that distance, and at the end we return that running total. Okay, so for example, for this one, we're gonna start with -1 because it's the previous index. So for first one we don't know, so we're gonna initialize it an array for the base case of -1, or basically a stack with -1. And then we start our loop. First encounter is 0, so it's open parentheses, so we store the index as 0, and then we move on. Next one is the close parentheses. Now we don't need to insert anything, right? What we can do is here we can first pop this out because we want to actually encounter this close, so that means our this is well formed, so we actually pop that index out, and then we compute our result, our distance. So the way we're gonna compute our distance, our index is currently is at 1, right? So we say our result is going to be previous result, which was 0, so maximum of previous result, which was 0 because we haven't calculated. So the result was initialized with 0, right? And then what we did is we say current index, which is 1, right? And take the top element of the stack. Now after removing that 0, the corresponding index, basically we remained with this base case. So we say negative, and then we have -1, right? So that's actually plus, right? So 1 plus 1. So this becomes 2, and that's what we return. Okay. So let's take another case where we have these as well. Okay. So this is again well formed, and let me put a space here so we can actually put indexes. So 0, 1, 2, and 3. Okay. So we initialize our stack with -1 case, right? And then we start iterating over. So we found open bracket. So we say we already have -1. We added 0 index. Then we encountered another open. So we say add 1. Okay. Then we encounter close, right? Close parentheses. We got rid of our current top. Okay. And then we say the result is basically our current index is 2, right? So the result is max between 0 and 2 minus the top basically is 0. Okay, so this becomes 2. Okay, so our result is now 2. So we continue on, and now we encounter another of this closing, right? So when we encounter this another closing, we have corresponding. So we just remove that one too, and we compute our result again. So max between 2 and our current index is 3 minus, and you have -1, right? So 3 plus 1, right? So this becomes 4. So maximum becomes 4, and that's our result. Okay. So hope that is actually clear. So let's go ahead and write the algorithm, and that's going to be more clear. So longest valid paran, right? And we return an integer. Now here we're going to create our stack, the array-based stack or array-backed stack, and we're going to simply initialize our result as well. We're going to seed our stack with -1, and then we're going to iterate over. Now, when we are iterating over, we need index and character both. So we're going to use Swift's power to basically enumerate. So we're going to say index comma char in s dot enumerated. Okay, in other programming languages, what you can do is you can simply do for loop and convert this string into a character array. Okay, so that way it's going to give you the same result. Now you say if the character, the current character that we are looking at is an open paren, right? We say stack dot append that index. If it's not an open paren, that means it's a closed paren. First thing we do is we remove last, basically the corresponding index, and then we say if stack is not empty, right, is empty, in that case we simply say compute the result as max between result and the index minus stack dot last. Okay, so whatever last means basically peak. If that's not the case, stack is empty, then we're gonna say stack dot append index. Okay, so we just put the current index into it. Now this loop is gonna run through, and then we're gonna simply return the result. Okay, so let's take a look at some examples. Okay, so I'm gonna create. So you're gonna run through some examples and see if it works for us. So I'm gonna say input. I'm gonna create a variable input, and I'm gonna put all of our strings into it. So the ones that we checked. So it's going to be open, valid, close, right? And simply going to say for I in input, and here we simply say print this guy right here and supply I into that. Okay, so let's go ahead and run this. What we should get is 2, 4, and 4, right? So if you take a look, actually, you're gonna notice that this 2, 4, 4, the way it's actually coming is for the last one, you have 2 invalid parentheses in the list, right? So these two, right here and right here. But if you look at the middle, this parentheses set, this is actually valid. So that's where we actually say that this is valid, so return its length. So that's going to be 4, right? And you can do another check. You can put like this. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. Sorry. Kind of like that. Okay. So let's compute. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, I think. Yeah. So that's 8. Okay. So that is the solution for longest valid parentheses or longest valid substring in a parentheses substring in a given string problem. Okay. So, and that's how you solve it using stacks. So hope that is that's actually clear. Go over the algorithm one more time and take a look at how each step is basically progressing. And yeah, so hope you guys enjoyed this video, and thanks again for watching. I'll see you guys in the next video. Thank you.